Why do birds perch on high-voltage power lines without getting electrocuted? What hidden law of nature protects them from instant death? And if electricity is so dangerous, why aren't these tiny creatures roasted on the spot? Could a human do the same and survive? What would happen if a bird accidentally touched two wires at once? And more intriguingly, what does this reveal about how electricity actually flows? In the next few minutes, we're going to unravel one of nature's most deceptively simple mysteries, one that combines physics, biology, and a dash of danger. You'll never look at a bird on a wire the same way again. If you enjoy fascinating science explained in a way anyone can understand, make sure to like this video, subscribe to the channel, and leave a comment telling us your favorite bird. To understand why birds don't get shocked, we need to understand how electricity behaves. Electricity is like a restless traveler. It's always looking for the easiest and fastest path to reach the ground. The ground acts like a magnet, constantly attracting electric current. For electricity to flow through a body, there must be a difference in voltage between 2 points, just like water flowing downhill from high to low. Without that difference, electricity stays put. Now picture a bird landing on a single power line. That bird's 2 feet are touching the same wire, and therefore they are at the same voltage level. There's no difference in electrical potential, no hill for the current to roll down. So the electricity has no reason to pass through the bird's body. This principle is the reason why they survive, not because the electricity isn't dangerous, but because it has no motivation to pass through them. It's all about the path of least resistance, and in this case, the wire itself is a better highway than a bird's body. Shocking. Maybe not yet, but just wait until we add more variables into the mix. Now that we know a bird is safe if it stays on a single wire, let's talk about when things get risky. The key word here is difference, specifically a difference in voltage. If the bird were to touch 2 wires at once, or 1 wire and a grounded structure, things would go very wrong, very fast. Let's imagine a pigeon stretching its wings. If it happens to touch a neighboring wire that's at a different voltage, electricity suddenly has a reason to move. That voltage difference becomes a downhill slope, and the bird's body turns into a bridge for current to cross. In an instant, that harmless perch becomes a lethal shortcut to the ground. It's not the wire that's deadly, it's the combination of 2 points at different voltages. That's why you'll sometimes see large birds like eagles or owls avoid clusters of wires entirely. Instinct or learned behavior? Maybe both. And the same rule applies to humans. If you touch just 1 live wire while staying completely isolated from the ground, you might walk away unharmed. But the moment you create a path for the current to exit, even accidentally, that's when danger strikes. Birds don't understand voltage or electrical current, but their natural behavior keeps them safe. Over time, evolution and survival instincts have led birds to prefer perching on single wires, especially those suspended far above other structures. These wires offer height, visibility, and a perfect rest stop without nearby obstacles. You might notice birds rarely land on transformers, poles, or metal supports. That's because these structures are often grounded, meaning they're directly connected to the earth. If a bird were to land on a wire and brush against one of these grounded elements, it would instantly become a conduit for electricity. But on a clean stretch of wire, uninterrupted and far from other conductors, the bird's body doesn't offer an easier path for electricity than the wire itself. The metal inside the cable is far more conductive than flesh and feathers, so the electricity stays where it is, flowing peacefully through the wire, ignoring the bird completely. It's almost like the bird isn't even there, as if it's found a way to become invisible to the current. And in a way, it has. Let's take a closer look at the battle between wire and bird. At a microscopic level, electricity always chooses the path of least resistance. And when it comes to conductivity, metal wires are like superhighways. Copper and aluminum, common materials in power lines, have extremely low resistance, allowing electricity to flow freely with minimal effort. Now compare that to a bird's body. It's made up of tissues, fluids, bones and feathers, all of which are much poorer conductors. Even if the current had the option, passing through the bird would be a far slower, more difficult journey than staying on the wire. So, unless the bird creates a second contact point at a different voltage, the current has no incentive to change direction. This difference in conductivity is crucial. A wire offers almost zero resistance. A bird offers a lot. It's the same reason your phone charger works better plugged directly into the wall than through a potato. It's not about what's connected, but how efficiently current can travel through it. So when we see birds perched calmly above cities, farms and forests, they're not defying danger. They're simply not giving electricity a better option. At this point you might be wondering, if birds can sit on power lines safely, could a human do the same? Technically, yes. But practically it's extremely dangerous and almost never ends well. The reason lies in scale, balance and environment. Birds weigh just a few ounces and can land gracefully on a wire without touching anything else. Their small feet and light bodies allow them to stay isolated. But for a human, even getting to the wire requires ladders, poles or helicopters, all of which are likely grounded or could cause accidental contact with other wires. And unlike birds, humans are big. Our long limbs and movements make it incredibly easy to touch two wires at once or brush against a grounded pole while still in contact with a live cable. That's why electrical workers wear heavy insulating suits and use tools specifically designed to keep them out of the current's path. It's not just about being on the wire, it's about staying completely within one voltage zone. Miss that detail and the consequences are deadly. So next time you see a bird balancing high above, remember, it's not invincible. It's just playing by the rules of electricity far better than we can. Despite their instincts and evolutionary advantages, birds aren't immune to electrical accidents. In fact, thousands of birds die every year from electrocution, especially larger species like hawks, eagles, and vultures. But why them, and not the smaller ones? The answer lies in wingspan and reach. Larger birds need more space to land, and their wide wings often stretch across multiple wires or between a wire and a grounded structure. That single mistake, just a few centimeters of contact, is enough to create a voltage difference, and in that moment the bird becomes a bridge for electricity to flow through. Birds of prey are particularly vulnerable because they prefer to perch on high vantage points like transformers or cross arms, where wires and grounded components are closer together. Engineers have even started designing safer utility poles with bird guards and insulation to prevent these deadly incidents. So while small songbirds can dance across power lines all day, for bigger birds, a single misstep can be fatal. Nature's laws don't play favorites, they only follow the rules of physics. As our world expands and electrical infrastructure reaches even the most remote areas, humans have started to realize that power lines can pose a serious threat, not just to people, but to wildlife. That's why engineers and conservationists are now working together to create bird-safe solutions. One innovation is the use of insulating covers on wires and components where birds are likely to land. These covers reduce the risk of accidental electrocution by preventing contact with energized surfaces. Another strategy is to increase the spacing between wires on power poles, making it less likely that a bird's wings will touch two at once. Some regions install perch deterrents on dangerous structures, subtly guiding birds to land in safer spots. Others even redesign entire utility poles with wildlife in mind, placing wires farther apart, shifting grounded hardware, or using visual markers that make the wires more visible. These changes don't just help birds. They also prevent power outages, reduce fire risks, and improve grid reliability. It's a rare win-win, protecting nature while making technology more resilient. So the next time you see a bird on a wire, remember, It may be benefiting not only from physics, but from decades of thoughtful engineering. When we watch birds perched on power lines, it all seems so ordinary, almost peaceful. But what we're really witnessing is a perfect balancing act between nature and invisible forces. The wires carry thousands of volts of electricity, enough to kill a human instantly, yet the birds appear completely unaffected. This everyday image hides an astonishing truth. It only works because of a fragile, invisible condition. The moment that condition breaks, if the bird touches another wire, a metal pole, or even another bird at a different voltage, everything changes. It's an illusion of safety. We assume the wires must not be dangerous because we've seen birds on them our whole lives. But that's the trap of familiarity. We forget what's really happening behind the scenes. Electricity doesn't care about the calm sky or chirping sparrows. It follows cold, exact rules. So when you look up and see a row of birds silhouetted against the sunset, know that they are dancing on the edge of danger, with absolute precision. Not because they understand the risk, but because their habits, anatomy, and instincts have unknowingly mastered the art of survival. Birds don't study circuits. They don't know Ohm's law. Yet through behavior shaped by survival, they demonstrate key principles of electricity better than most textbooks. By watching how they interact with power lines, we get a glimpse into the invisible world of voltage, current, and resistance. They teach us that electricity isn't just about wires and sparks. It's about paths, differences, and choices. No voltage difference, no current. Poor conductor, no flow. Touch 2 voltages, big problem. These truths don't just apply to power lines. They apply to how we wire homes, build technology, and stay safe around electricity. Understanding the subtle relationship between contact and potential can prevent accidents, save energy, and even inspire innovation. In a way, every bird on a wire becomes a tiny physics lesson in motion. It perches silently, oblivious to the deadly current beneath its feet, but perfectly positioned in a zone of balance. And the best part? They're everywhere. Outside your window, above city streets, across open fields, living proof that nature and physics can coexist in harmony if only we respect the rules. The next time you glance up and see a bird calmly perched on a power line, pause for a moment. That quiet silhouette is not just resting, it's participating in a delicate dance with one of the most powerful forces in nature. Electricity is coursing beneath its tiny feet, held at bay only by invisible rules and perfect positioning. It's not magic, it's not luck, it's physics, biology, and instinct working together in silent harmony. The bird survives not because it defies danger, but because it never invites it. This small wonder reveals a much larger truth. The world is full of hidden patterns and elegant balances waiting to be noticed. Sometimes, understanding a simple moment, like a bird on a wire, can unlock a new appreciation for the laws that govern everything around us. So next time someone asks, why don't birds get electrocuted on power lines? You'll not only know the answer, but you'll see the beauty behind it. If you enjoyed this journey, leave a comment sharing your thoughts, suggest a topic for our next video, and share this with someone curious like you. And as always, thanks for watching.